Welcome to Math with Mr. P. Today we'll be working on 6th grade math, chapter 1, lesson 1. What will we learn today? We're going to find the greatest common factor, and we're going to also learn how to find the least common multiple. Now, greatest common factor is typically referred to as GCF. Least common multiple will be referred to as LCM. It's very important that we learn these acronyms because these will be coming up a lot within our lesson. Now, before we begin, we need to go over a few things. What is a factor? A factor is any number that can go evenly into another number when we count by that number. So, for example, if we had the number 9, factors of 9 would include numbers 1 through 9. Nothing bigger than 9 can be a factor of it because it can't go into it if it's bigger than it. So, we look at the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, factors will always include 1 and the number itself, because 1 can go into any whole number evenly, and 9 can go into 9 as well. Now, factors, this means counting by that number. So if we count by 2, for example, 2, 4, 6, 8, 10, it does not go into 9 evenly. Therefore, 2 will not be one of these. We can now also eliminate 4 and 6 and 8 because they are even numbers and 9 is an odd number. 3 will go into 9 evenly if we count 3, 6, and 9. It goes into 9. And for the others, they will not go in evenly. 5 would be 5, 10, 15, 20, does not go in. And 7 would be 7, 14, 21, will not go in. Therefore, factors of 9 include 1, 3, and 9. That is a factor. Now, when we are talking common factors, what we're doing is we're comparing two numbers and trying to find out if there is a commonality between the two of them, meaning is there a number that can go into both of these evenly? For example, 14 and 21. If we were to look for a common factor between these two numbers, we would look for what numbers can go into those. Now, you can list off immediately knowing 1 and 14 would go in, and 1 and 21 would go in. Now, the rest of this would be guess and check, or unless you know your multiples, like for example, 2 times 7 would equal 14, and then 3 times 7 would equal 21, and so on. There is an easier way to try to find the factors. Now, the other thing we do need to review is multiple. I apologize for the handwriting as I am recovering from UCL surgery and have a brace, so my handwriting is a little bit sloppy. Multiples are any time you take that number and you count by that number. For example, going back to 9. If I were to count by 9, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 would be 27, 9 times 4 would be 36, 9 times 5 would be 45, and so on. Every single one of these numbers is known as a multiple of 9. Back before, I counted by 2s. 2, 4, 6, 8, 10, 12, 14, etc. Every single one of these numbers here would be considered a multiple of 2. Those are multiples. Now, going back to the greatest common factors, we are going to have to compare numbers, either 2 or more numbers, to figure out a common factor. So, for example 1, there are 1 slice servings with 3 types of cake on a table. Each row has an equal number of servings and only 1 type of cake. What is the greatest number of servings in each row? To solve this problem, we use common factors. We are going to be utilizing the numbers 10, 15, and 20. Over here, they already list our factors of 1, 2, 5, and 10 for 10, 1, 3, 5, and 15 for 15, and 1, 2, 4, 5, 10, and 20 for 20. Now, let's take this information and let's try to do this in an easier fashion. We're going to take the original numbers, 10, 15, and we're going to use a different number or a different color for 20. Now, what I could do is start counting by numbers that are less than these and try to figure these out, or think of my multiplication. But there's an easier way of doing this, and this is called a prime factorization tree. What you want to do is think of any multiplication facts or problems that can equal these numbers. For example, 10 would be 2 times 5. 15 would be 3 times 5. And if we're keeping in the 5s, 20 would be 4 times 5. Now, prime factorization deals with the factors that are left over being prime. Therefore, right now, 2 and 5 are factors of 10. 3 and 5 are factors of 15, and 4 and 5 are factors of 20. However, we are not done factoring everything. I can lock in 2 and 5 because these are prime numbers. Prime numbers meaning no other factors go into them, or no other numbers go into them. They don't have any other factors except for 1 in itself. 1 and 2 can only go into 2. 1 and 5 can only go into 5. The same can be said for 15. Only 1 and 3 can go into 3, and only 1 and 5 can go into 5. Therefore, I can't break these down anymore. However, this 4 can be broken down into 2 times 2. This 5 can't be broken down, so I bring down this 5. Now, the reason why I do this is because if I were to multiply all these three numbers, it will equal to 20. This is its prime factorization. And the reason why I do this is because that way you can compare factors. 2 times 2, which would equal 4, times 5 would equal 20. Therefore, this is its prime factorization. 2, nothing else goes in it besides 1 and 2. Again, nothing goes in it besides 1 and 2. And again, nothing goes in 5 except for 1 and 5. I will be updating our class OneNote with this prime factorization chart. These are prime numbers. All of these numbers only have factors of 1 and itself, meaning no other numbers are able to go into it evenly. These are a list of prime numbers up to 1,000. This will be added to your OneNote shortly. Now, when we look at the numbers that are left over, we look at the highlighted portions. I'll highlight it in a different color. The 2 and the 5 here, the 3 and the 5 here, and the 2, 2, and the 5 here. The number they all have in common is 5. 5 being the greatest common factor between 10, 15, and 20. Let's try a different one. Lana earned $49 on a Friday, $42 on a Saturday, and $21 on a Sunday selling bracelets. She sold each bracelet for the same amount. What was the most she could have charged for each bracelet? Now, we're going to take those three numbers and we're going to write them down on our whiteboard. We had 49. Change the color. 42. And I believe our last one was 21. Now, unless you know the factors right off the bat, we are going to have to do some math. Now, I know 49 can be 7 times 7. I also know that 7 is a prime number, so therefore, we are locked in here. 42, I don't know off the top of my head, but I know 42 is an even number, therefore 2 will have to go into it. Now, mental math. 42 is made up of 40 and 2. If I don't know what half of 40 and 42 are, I can do this. Half of 40 would be 20. Half of 2 would be 1. 20 and 1 together makes 21. Therefore, I have to multiply 2 by 21. Now, 2 is a prime number, but 21 does have other factors. Now, since I can't break down the 2, I just bring it down. But 21 is made up of 3 times 7. 3 and 7 and 2 are all prime numbers, therefore, we lock in. We cannot break that down anymore. And last but not least, 21 is literally just made up of 3 times 7, like we just said, and we are locked. Now, we look at the biggest number that they all have in common, which is 7. Therefore, the greatest common factor between these three numbers is 7. And technically, I would like to box the whole answer out on your homework. Therefore, the most money she could have charged for a bracelet was $7 to have an even amount at the end. In example 2, we show the prime factorization tree happening. 12 is 6 times 2. The 2 cannot be broken down. It gets brought down. 6 can be broken down into 3 times 2. And then we have our prime factorization right down here. 18 can be broken up to 2 times 9. 2, which can't be broken down, still gets brought down. 9 can be broken down into 3 times 3. Therefore, we are done. Now, here's the trick when we have more than one. When we have more than one common factor, we take the 2 numbers or 3 numbers or however many numbers they have in common, and we actually multiply them together. 3 and 2 in this example, and the 3 and 2 here. Now, this 2 doesn't have another partner, and this 3 doesn't have another partner, so we just ignore them. 3 and 2. 3 times 2 would equal 6. Therefore, the greatest common factor would be 6. Now, we're going to pick one of these, and we're going to do the example, and I think we're going to do example C, 18 and 30. Now, we're going to find the greatest common factor between 18 and 30 by prime factorization. I'm going to turn this one blue, so this will be 18. And we'll do this one green, 30. Now, it doesn't matter where you start. The good thing is if it's an even number, you know that 2 is going to be in it. But 30, I know, is easily made up of 3 times 10. That's the route I'm going to go. If you went any other route, it's fine. You'd still end up with the same factorization. So if I started off with 5 times 6 or 2 times 15, I will still end up in the same spot. 3 is a prime number, so I'm going to bring it down. 10 can be broken up into 2 times 5. Now, 2 and 5 and 3 are all prime numbers. I'm going to lock in. Now, before I do this, I'm going to show you what would have happened if I did 30 a different way. So let's say I broke up 30 into 5 times 6. The 5 is a prime number, bring it down. 6 can be broken up into 2 times 3. I would still end up with 5, 2, and 3, just like I did here, just in a different order. And if I decided to break this into 2 times 15, my 2 would still come down, and 15 would be broken up into 3 times 5. Still ending up with 2, 3, and 5 at the end, just like I did right there. So, as long as your factors actually equal the number you're breaking down, it doesn't matter which one you start with, you'll be fine. 18, I know, is an even number. Oh, didn't want that to happen. Therefore, it will be broken down by 2. Now, I don't know 18 off the top of my head. I know 18 is made up of 8 and 10, so I'm going to use mental math. Half of 8 is 4. Half of 10 is 5. 5 plus 4 equals 9. Therefore, 2 times 9 will equal 18. Now, I know 2 is already as small as it can get. It's already a prime number. 9, however, is not. We will multiply 3 times 3 to get 9. And I am now locked in because they are all prime numbers. However, I'm going to look at which numbers they have in common. This one has a 3. This one also has a 3. I'm going to ignore the other 3 because the other 3 does not have a partner over here. There is no other 3 here to pair it up. Therefore, that 3 is now canceled out. Same thing with this 5. There's no 5 on the other side. However, there is a 2 here and there is a 2 here. Therefore, my greatest common factor is 3 times 2, or better way to put that is 6. 3 times 2 equals 6. We'll do one other example here from that list, because I wasn't expecting to have the same answer of 6. So we're going to look at 12 and 66. Now, I know that number looks pretty daunting, but trust me, this will be pretty easy. 12, and I'm going to double check before I do something wrong, It is 66. Always double check to make sure you're writing down the correct words or answers. 12 will be 2 times 6. 2 will not be broken down. 6 will be broken down into 2 times 3. And those are my prime factorization for 12. Another way for you to check is to actually do the math. 2 times 2 would equal 4. 4 times 3 equals 12. Therefore, this does check off. 66 is going to be a little trickier. I know it's an even number, but I also know that 6 times 11 can get me 66. So I'm going to go with that. Now, 11 is a prime number. You can always check the prime factor chart once it's uploaded onto OneNote if you're not 100% sure. And 11 is right there for us. So 11 is a prime number. Therefore, the 11 will just come back down. 6, however, can be broken up into 2 times 3. These are all now prime numbers, therefore we are locked in. Each one of these shares a pair. There's a 2 here, there is a 2 here. There's also a 3 here, and there's a 3 here. The other 2 gets ignored, and the other 11 gets ignored because there's no pair there. Our greatest common factor will be 2 times 3, which will in fact equal 6. Therefore, 6 is our greatest common factor. Now, to find the least common multiple, we are going to take each one of our numbers and we can put it on a number line and we can start counting by those numbers. For example, multiples of 2 would be 2, 4, 6, 8, 10, 12. If you look here, we put 2, 4, 6, 8, 10, and 12. Multiples of 3 would include 3, 6, 9, 12, 15, and then you can keep going. 3, 6, 9, 12. Now, we're looking for the least common multiple. So which number shows up first together when we count by these? For 2 and 3, the answer is 6. 6 is the first one that shows up when we count by these. Now, there's got to be an easier way to figure this out. The least common multiple of 14 and 21 using prime factorization. When we use prime factorization, 14 and 21, we notice that 14 is 7 times 2 and 21 is 7 times 3. 7 is the only common prime factor. Therefore, 7 is the least common multiple. Oh, sorry, wrong. 7 is not the least common multiple. 7 is the least common factor. The least common multiple would be 7 times 2 times 3. Let me rephrase what I just said. So ignore what I just said because I made an error. We see the common 7, yes? OneNote would work. So we take that 7 and put it over here. What we then do is we take every other number that is not common. So what we did here is we take the two 7s together and we cancel one of them out. Now what we would do is 7 times 2 times 3. We take the other factors that are left over. 7 times 2 would be 14, and then we do 14 times 3. 3 times 4 would be 12, carry the 1. 3 times 1 is 3, plus the 1 would be 4. Therefore, the least common multiple is 42. I apologize, I had factors stuck in my head. Remember, 14 and 21. I'm trying to remember 14 and 21 so I can erase the screen and we can do this. Now, multiples would mean I'm going to count by those numbers. So I'd do 14. Double 14 would be 28. If I were to add 3 more, 8, 9, 10, 11, 12, carry the 1, that'd be 42. And 21 would be 21, 42, and so on. And you can already tell that 42 is right there in common first, like we have our answer over here. When we use prime factorization, we're going to look at the ones that they have in common, and then we are going to take that number away separately one time and multiply it by the other numbers that are there. Now, I know that sounds a little bit confusing, but we will do this with 3, 5, and 7. Now, we are going to prime factorize 3, 5, and 7. The good news is every single one of those is a prime number. 3 is only 1 times 3. 5 is only 1 times 5, and 7 is only 1 times 7. The good thing here is, and there's a little trick, if you have a bunch of numbers that are only prime numbers, the lowest common multiple of these is literally going to be us multiplying these three numbers. Now, 3 times 5 will equal 15, and you can do 15 times 7, or you can do 7 times 5, which is 35, and multiply that by 3. Either one is fine. I'm going to pair this one first. Actually, lies. I'm actually going to do a different way. I'm going to multiply 3 and 7 together, which equals 21. Now, I need to multiply it by 5. I like multiplying by 5s. I think it's a lot easier, so this is why I would do this. 5 times 1 is 5. 5 times 2 is 10. And that's it. The least common multiple of 3, 5, and 7 is 105. And if you were to sit here and completely count these out, you would see that it would be 105. Because 3 would not go into anything that 5 could go into until about 30, and then 60, and so on. 3 doesn't go into 70, and 7 wouldn't go into any numbers by 5 until 35 or 70 or so on. 105 is the lowest common multiple between these three numbers. Let's do a different example. Least common multiple between 6 and 15. And we'll wrap this up after this one. 6 and 15. Now we're looking for common multiples. We're not looking for factors. So don't let me hiccup again like I did earlier. LCM is what we're looking for, the least common multiple. I am going to prime factorize these because I do need to figure out what factors they have in order to find out how to identify their least common multiple. Now, 6 will be made up of 2 and 3. 2 and 3 are prime numbers, therefore I lock in and I'm good. 15 will be made up of 3 times 5. And those are also prime numbers and I lock in. Now remember, the trick with trying to find the least common multiple is looking for a number they have in common. They both have 3 in common. Therefore, one of these 3's will be canceled out. Therefore, our least common multiple will be the 3 that we had in common times the 2 that was left over times the 5 that was left over. When we solve this, this should give us our least common multiple between 6 and 15. 3 times 2 will be 6, times 5 will equal 30. Our least common multiple should be 30. Now, let's check. This is an example where I can count by these numbers, and it won't take me forever. 6, 12, 18, 24, and 30. The other number was 15, which would just be 15 and 30. If I wanted to keep going, I could do 45 and then 60, but 30 here would be the least common. It's the first number that shows up that they both have in common when I count by that number. It still is the answer that we had earlier. If you have any questions, you can go ahead and leave a comment if you're not in my class. If you are in my class, please bring questions tomorrow and we will go over them. Your homework will be found on the OneNote. For those in my class, you have 11 questions. And remember, bring your notes, bring any questions that you have. And again, this is Mr. P, logging off.